Poisson distributions and binomial distributions they're both fairly similar. The big difference being with a Poisson distribution is you're generally only given the mean value. So let's have a look at this problem right here. We're told a can company reports that the number of breakdowns on an 8-hour shift follows a Poisson distribution, and the average number of breakdowns is 1.5 over that particular time frame. And that's one thing that distinguishes Poisson distributions from binomial, is that you're usually counting the number of times something happens over some given unit of time or area, volume, or whatever. Okay, so in this problem, all we're told is that the mean is equal to 1.5. We're not told a sample size. We're not talking about a population proportion. None of that. So let's look at these questions. What is the probability of exactly 2 breakdowns? So for this one, I simply want to know what's the probability x is equal to 2. In part B, what is the probability of fewer than 2? Fewer than 2 is going to include 2, 1, and 0. So for that, I could use cumulative probability. And then we're asked what is the variance. And on the slide above, we are given a formula for variance and standard deviation. So let's just go to the next slide here for a minute. And here's my solution worked out using the formula. So when you use the Poisson formula, you need the mathematical constant e. You are raising that to a negative mean of the distribution, which in our case we're told the mean is 1.5. So notice I've got the 1.5 there. Then lambda itself is my mean, 1.5, and I'm looking for the probability x is equal to 2. I throw that in there over 2 factorial, work this out on my calculator, and I'm going to get to 0.2510. Okay, great. And we'll go into Minitab in a minute and show you how to do this. Now, in the second part of the question, what's the probability x is less than 2? So less than 2 includes 1 and it includes 0. So if I was working this by hand the long way, I'd work out those 2 individual probabilities, I'd add them together, and that would be my answer. Now, your note down here says we could also answer part B using cumulative probability and find x less than or equal to 1. Now, notice that that says less than or equal to 1, and my problem says find me the probability that x is less than 2. But keep in mind, x can only be whole numbers, so if it's less than 2, it can only include the numbers 1 and 0. Alright, let's go to Minitab here for a second and see how we might do this. So I'm going to the Calc tab, Probability Distributions, and halfway down in your list you've got the Poisson. Okay. All I'm being prompted for here is the mean of this distribution, which I'm told explicitly is 1.5. In answering part A of the question, I want equal to probability. I'm going to come down here, input my constant, which is 2, and there's my answer, which is the same you would get if you worked it out with the formula. In the second part of the question, we wanted to know what's the probability of less than 2, but keep in mind that less than 2 is the same as the probability of 1 or less. So I'm inputting 1 and I'm changing my radio button to say cumulative. Click OK, and I get the probability that x is less than or equal to 1. So this includes my probability of 1 plus the probability of 0.